Hello everyone, good morning, good afternoon. I'm from Jain to India. Today I'm excited to present Rest Powered Data Engineering, building performance critical systems for global impact. In a world drowning in data, or 175 zettabytes processed annually, how do we build systems that are fast, secure, and ready for global challenges? That's what we will explore. Imagine processing petabytes of data without crashes or breaches. Traditional tools like Java or Python often fall short. Garbage collection cause unpredictability, memory leaks, risk corruption. We need to rethink for safety and scale. Rest offers that performance of low level language with high level safety. So, why Rest? Let's break it down. First, memory safety. Rest ownership model tracks who owns data, preventing bugs like null pointer at compile time. No runtime overhead, zero cost abstractions that lets you write clean code without slowing down petabytes processing. Concurrency in the list. The compiler catches race conditions, so no more debugging deadlocks. And also on the productivity, no garbage collection means consistent performance like C++, but safer. In my experience, I've seen teams spending weeks on memory issues in C++, and Rest eliminates that. These aren't hypotheticals. Rest delivers 10 times throughput over JVM tools in streaming, 99.99% uptime for massive workloads, 80% lower latency at the edge, and 60% saving via zero copy. Production, this means handling billions of records without hiccups. Think about your own pipeline. Could you use an 80% latency cut? Rust isn't alone. Tokyo powers async I/O for high throughput. Apache Arrow enables fast columnar data, great for analytics. Data fusion is like a Rust-based Spark for queries. The ecosystem is booming, making Rust practical today. But does this work in real world? Let's take a look at the case studies. The first case study is on a client monitoring system, where terabytes of satellite data is stored in remote spots, needing real-time analysis on limited hardware. Rest solution would be to develop efficient pipelines that run flawlessly on the edge, which help us in providing 65% faster processing, 40% cheaper infra, and reach to remote areas using this edge technology. This powers global climate impact and think monitoring deforestation in real time. For environmental engineers here, this means deploying AI where it's needed the most. In health systems, public health systems, national scale, city data for epidemic tracking, no room for errors. Just ensures memory safety and privacy at compile time. With queries hitting 8 millisecond on billions of records, zero breaches, near perfect uptime during crisis. This even saves lives by enabling instant insights. These wins comes from Rust, and let's deep dive on those. Rust ownership is key. It prevents corruption by enforcing single ownership or borrowing. No buffer overflows, all at compile time. This makes data flows clear and maintainable, perfect for complex pipelines. It's like a strict librarian where you borrow a book, but obviously you can't keep it forever or lend it out twice. Here is async processing with Tokyo, which read lines with zero copy. It processes without copying data. And also at the source, parses the streams efficiently. And once it has parses the stream data, it can also transform the data in parallel without locks, which in the next step can serialize safely to the data sink. This avoids overhead in high volume data. While loop also reads without blocking, clears buffers to reuse memory. Code creates arrays and batches zero copy. We share data without duplication. Columnar data is used for fast queries. It also integrates with Python, which is ideal for mixed language teams. And if you're in analytics, Arrow's columnar format speeds up aggregation massively. Building ethical data systems with Rust, where also we need to take a look at the efficient query execution. And this is also SQL is to optimize execution, where you can register your CSV, for example, run query like AVG temperature with average temperature with filters, and it can provide you the zero copy results. And this itself is a example of data fusion in action, which is vectorized for speed. Rust isn't just fast, it is ethical too. Ownership enforces privacy boundaries, efficient bias detection in ML without slowdowns. It is also sustainable because it takes low energy to process these data, which in turn cuts carbon. Rust lets us build responsibly at scale. At this side, it talks about the lock-free with or automation. And the code shows a safer counter where streaming with Tokyo Arrow provides higher throughput. It also optimizes for energy savings. So start small, try a Rust pipeline in your next project. These are just plug and play. Experiment to see this in action. Trends, the future trends of Rust in data engineering. Obviously, Rust is cloud native, ML is integrated. This is also a specialized tool which provides us the performance and safety at lower cost, fewer vulnerabilities, global scalability, and this is why Rust is the future of data engineering. In summary, Rust transforms data engineering for impact, fast, safe, and ethical programming. Thank you.